So in the last video, we created the first digital asset for the Talented Bald project. Very simple, just our floor asset. Obviously, if we were treating this very seriously, we would have gone in, just put a grid down, end of story. But we wanted to present the floor asset as kind of a refresher from the fundamentals course, just making sure everybody's still with us for creating a digital asset and promoting our parameters up so that an artist can use them. Now in this video, things are going to remain simple, but we're going to get a little bit more involved because now we're going to start needing to use expressions. What we're going to create is going to be the stage. And the stage itself is very simple, but we need to create it in such a way that an artist can go in and simply change the radius of the legs, which you'll see in just a second what I mean when I say the radius of the legs. And everything's going to react properly, or if they want to change the width or the depth of the stage itself, all of the legs remain in the correct place. So in this particular video, we're going to have to get into some simple math. So let's go and get started. First, I'm going to jump over to the whiteboard, and here's what the stage is going to look like. So if I was to draw a very cheesy three-dimensional view of the stage, we end up with basically a box that has been horribly drawn here. It's been stretched out like such, and what we're going to use for our legs are simply going to be spheres. So up underneath this box, we're going to have spheres down there. So, wow. Hey, we got like all sorts of different clicks on that one. For some reason, the Wacom tablet seemed to have lost the mouse for just a second. So there you go, and the other guy, of course, is sitting back here in the distance. Now, in designing this, you need to take a few things into consideration. First of all, an artist must be able to change the width and the depth of this guy. And as he does, our legs, as we're going to call these spheres, must remain on the outer edges. Just not all the way out, just in enough to where they're sitting up underneath the stage floor holding it. Okay? We also need to be able to change the radius of these spheres, and as we change the radius, the floor itself must remain sitting on top of the spheres. Now, all of this is very, very easy to do. So let's go ahead and spend just a second and talk about how we're going to pull this off. So first thing, let me see how I'm going to draw. All right, let's just start this way. And I'm going to have to give you a relatively straight line. Some of this is going to be kind of important. All right, when we first create a box, Steve's going to go in there and just throw some quick numbers in to give us a shape, but those aren't going to necessarily be the numbers that we're going to use for our project in the end. But we just want to give some sort of rectangular shape. Now, at the moment, what we're looking at is a side view of this guy. Now, when we create the box and we adjust his size, the box is still going to be cutting through the center, the origin, our construction plane. And what we want to do is we want to take this box and sit it up on the construction plane. So again, this is where we just have to think about using just simple math to make this happen. So how are we going to do this? Well, we have a height. If we take 1/2 of that height and translate our box up in Y, 1/2 of that height, we will end up with this guy sitting exactly where we need to sit it. Here's an example. Let's say that I'm going to draw this. This is going to be a very stubby stage right there. And let's say that this guy has a height of 10 units. Okay? If we were to take half of it, well, first of all, if it was 10 units, that means sitting up high, we're going to be a +5, and sitting down low, we're going to be a -5.
Exactly.
If we were to take that 10, that's its height, divide it by 2, what are we going to get? We're going to get 5 out of it. Well, if we move up 5 units, so this is -5 sitting down here. So if we move up 5 units, where are we going to be sitting? On the construction plane. And we'll be 5 units higher here.
Very cool.
So that's exactly what we're looking for. So to move this guy up, we'll just simply say, all right, take half the height, translate in Y, up half that height. And there we go. Now the next thing we're going to need is a simple sphere. This one sphere is going to end up representing all 4 spheres, and that's the cool thing about Houdini, and that is that we have the ability to go back in history and branch off of a network and suddenly start working with new numbers. And if we were to merge that in to a branch of the network later in the future, it suddenly looked like we got 2 spheres, where in essence we really just started with 1. So when we start with a single sphere, we're going to have a single sphere that is going to be sitting right here in the center of the origin. We want to move this guy down. So far, with this guy right here, what we've managed to do is the following. So if I come in here and, again, let me just grab for the shift key, draw this out real quick. He's been moved up such that he is sitting on top of our construction plane. Now, if I take that sphere and take his radius, take the radius and subtract that away in Y, that is going to move the sphere down below the construction plane, but such that the top of the sphere will touch the top of the construction plane. So that will result in this. So he's just touching the top. And since we're using very simple mathematical expressions where we're saying take the radius, subtract away the radius. As the radius gets larger and larger and larger, what's going to happen to the radius? It's going to move further and further away. So let's say we've just tripled our radius size. We're still going to be left. It's an awful looking circle, but we're going to be left with that. It's still going to be sitting in the right place in relationship to the construction plane and to the box.
Yeah, and if we were to take the height of the box, so its size in Y, and we were to change that, the box is still going to sit with its bottom on the construction plane. So the box is always going to sit so that it's just touching the sphere, which is perfect for what we need.
Exactly. All right, so basically here for this guy, all we did was we simply just subtracted away in Y the radius. Okay? So again, we're working with our translate Y. And same thing over here, working with our translate Y. Just reminders. Now, let's go ahead and switch over to a top-down view so that we can start discussing how we're going to get the sphere and spheres into place. So top-down view. Notice I have to get all quiet when I try to draw straight lines. This is challenging.
Oh, they're good straight lines, man.
There you go. Thank you. All right, so we're starting out. This guy's right here in the center. Now, what we want to do in the end is have one guy that's positioned here, one guy here, one guy here, and one guy here. Notice how these have been drawn. They're edges. If we were to look at a bounding box around each of the spheres, which means basically the sphere sitting inside this perfect box where the box just does touch the sides of the spheres, okay? We would see that the box would be flush with that edge, flush with that edge, and we'd see this all the way around. Flush over here, over here, up here, here, and down here. So how do we accomplish this? Well, it's real simple. First of all, let's say that this is X going across, just say that's our width. And let's say this is the Z direction and our depth. So if I wanted to take this guy and start out by moving him over here, what do I need to do? Well, there's two different directions that I'm going to need to move in order to get him into that corner. First, I'm going to need to move in X, and that's simply going to take the sphere in that direction. Then I'm going to need to move in Z so that I move the sphere down in this direction. Now let's think about it logically. How far do we want to move? Well, we have these numbers such as X, Z, and even the radius for this guy right here, which is going to be very important in just a second. So the first thing we can say is, all right, well, what if we were to take this guy and move him 1/2 of X? That means take this entire distance over here. Let's say that distance was 20. What if we moved half? So divided by 2, we end up with 10 units. Well, that's 1/2. That's the other half. So if we were to move them over in half, now bear with me for a second. I'm going to erase a little bit of this just to kind of clean things up so that we can see exactly what's taken place. There we go. If we were to move him over half, that radius would be sitting, the center of the sphere would be sitting right there on the edge. So we'd get that. So if I said, all right, move him over in X, and let's say that this is a positive direction, this is a negative direction. So if I said just subtract away 1/2 of X, I'd say subtract away 10. That would put us all the way back over here. That's not exactly what we're looking for. We still have the sphere hanging out from up underneath our stage floor, so we need to move him back in some. Well, how far do we need to move him back in to comply with the specification that we set out at the beginning, where if there was a bounding box, the bounding box would be flush with this edge? Simple. The radius. See that radius right there? If we move that amount back in X positively, we'll have him sitting exactly where we want. So if we were to say, take this guy right here, which was 10, and then add to it our radius for our sphere, that's going to bring us back over. So again, bear with me. I'm going to take the eraser real quick, come in here and clean this up. So we're left with this.
And it's worth noting at this point, you could go either in negative X or positive X.
Absolutely. I just happened to pick this direction because it was one of the fundamental videos that we did. Oh, it was the stool, where we were taking the leg and we were going in a negative direction for it. So cool. Just following along with that.
So if you were to go in the other direction, you just had to think about your maths and invert some of the signs, but you can go whichever direction you want.
In this case, I'm just subtracting away, but if I'd have gone in the other direction, I would have added 1/2 and then subtracted away the radius to go back.
Fantastic.
Okay? Good point out, Steve. Okay, so now we've got this guy flush as far as this edge is concerned, but we now need to take and move him down in this direction. And this is where Z's going to come into play. So now we're going to move over to another channel, and we're going to simply say, and I believe when we start out, the network's going to kind of start out like this. We're going to start out with a sphere, and we're going to use our center to get this guy moved over in X,
and then in
and
Z.
then down in Z. Okay, and we're also going to use Y as well.
It's Y for sitting it underneath the construction.
Exactly. So here's the sphere. So again, it's the center channels that we're using. So now we're focusing on Z, and all we need to do is, once again, if we take all of Z, so let's say that that's 10. If we were to say take half of that, so divide by 2, we would be moving half this distance, which once again would put our center point right here. So our sphere would be hanging out. But it would still be flush up against this edge. Okay? All we would need to do at this point is simply subtract away the radius again, or add. Once again, it just depends on which direction you're going. But we would need to add back to get this guy to move in like such. And how much? Simply the radius of this guy. And by doing that, we would finally be left in a situation where I'm just going to clean all this up real quick. Our sphere is sitting flush with both of these sides of the stage floor, or our box. Just like such. Perfect. We now have one of these guys beautifully positioned. Now, I'm going to move him. I know that this guy is exactly where I want him to be. Now I'm going to take the output of this guy and I'm going to tie him into a transform. So XFRM, transform. Where do I want to transform him to? I want to move him so that he's sitting right there. All right, well, let's think about this logically. Well, how far do I need to move him? Well, if I was to take all of Z and move him in all of Z, where is he going to be? Let me erase some of this real quick. Thank you guys for bearing with me. We're doing all sorts of lovely drawings. If I said move all of this distance, 10 units, that means the backside of the sphere is going to be flush up here with this wall. Because from here to here, so this space right here, that is the Z distance right there. Okay? So far, so good. But I need to bring him back in so that he's up underneath the box. So now, it's not just one radius that move him back, because here's a close-up of what we're drawing. So we've got this. Now, if I moved him back, this radius right there, what would we end up having? We'd have that. It's close. Closer. What if I moved him 2 times the radius? Then we'd have that. So we need to simply move him the entire Z direction and then come back twice the radius, and that will have him sitting flush inside. So let's go ahead and draw that real quick. So kind of clean things up. Now we have this sphere transformed so that it's sitting right there. But we only have one sphere. But the magic of Houdini.
It truly is the magic of
Houdini. If I take that guy and also take out of this guy and wire both of these guys into a merge and turn visibility on, I would suddenly see both of these spheres sitting there. Absolutely beautiful. Now what I need to do is take these two spheres, because you don't want to work with them individually. We can work with both of them at the same time. That's brilliant. And I need to move them in this direction so that they will end up in the end being positioned on that side of our stage floor. So how far do I need to move them? Well, to move them means I'm going to first need to wire into a transform node. I'm just going to put XFM. There we go. I need to move this entire distance. So if I say move X, that's going to result in these two guys being moved just a tad bit too far. They're moved right outside the stage.
Yeah, when we say move X, as in move the box's X, the size of the box.
The size of the box. This
Fantastic.
X right there. So again, that was 20 units per my example down here. So they're not starting right here flush with the line. They've already been moved in. Their centers are down here, right? So since they're moved in a little bit, when you move them 20 units over, they're going to be sticking out on the side. So how far do we move them back? It's exactly like this guy right here where we were sticking out on the other side. All we need to do is subtract back away their radius times 2. It's as easy as that. If we subtract back away the radius times 2, they'll be sitting here. They'll be sitting there. And if I come in here real quick and erase this out, and then point out, we are now flush with that, and we already know that over here is good. So we're flush all the way around. Now, since everything has been based on the width and the depth of the box and the radiuses, our expressions are always going to update the values that are being fed to those channels anytime any of the values get updated, such as the radius gets updated. Boom, everybody is just happy. Now, having this, though, we almost are done with our network. The only problem we have is if we were to look at things, if our visibility flag was set right here, all we see are two spheres on that side of the box. We don't have two spheres on the other side. So now that we've got these spheres updating properly, all we need to do is take this guy out to a merge. M. Now, all we need to do is take the output of this merge, which represented the spheres on the left side, and feed them in. Now suddenly we see 4 spheres. Obviously we created a box, so I'm just going to put a B for box. If we take the box and feed that in as well, set our visibility down here, you will now see a stage in which we can change the dimensions of the box or the radius of the sphere, and everything just works. So that is what Steve is about to create. Now, that's not going to be the end of the asset. We're going to then, in another video, create our shader, and then we're going to create our attributes that an artist can use to control a few things.
Yeah.
We're going to do some attribute promotion, some parameter promotion, and we're going to also going to create a very special parameter that will allow us to specify a floor. I got to be careful when I say create attributes because I don't want to confuse anybody, as we will begin talking about attributes a little bit later. We'll be creating parameters.
Yeah.
So most of it will be promotion, but we will be creating at least one very special custom parameter.
Yes.
that will allow us to specify a floor for this stage to sit on. So there's a quick look at the theory behind what it is we're going to do and why we're going to use the math we're going to be using. Very simple. Just divide by 2's and some addition, some subtraction. That's pretty much it. And you can see the network there on the right-hand side. So with that, Steve, let's go ahead and jump over into Houdini and get started.
Awesome. So let's jump over into Houdini. And let me just grab the keyboard.
Oh, I see you wanting to get all comfortable.
I'm going to jump up so that we're at object level. I
Okay.
pushed U to jump up. I'm going to push Tab and drop in a new geometry node, which I will rename to stage. I'm going to push Enter to jump inside, and I will delete out the file. I'm also going to change my visibility so that I'm hiding out all the other objects because I don't want to see my floor when I'm working with the stage. So let's start out and let's create a box. So I push Tab to bring up the Tab menu, type box, Enter 2 times to create the box. And let's create a box called stage box. I'm just going to give him some very simple sizes to begin with. Let's say 50 in X, 1 in Y, and 30 in Z. So something kind of stage dimensions. And I am going to uncheck consolidate corner points. That's going to give us hard shading on our box as opposed to the smooth shading, which doesn't look correct. It's a nice hard shading, everything looks clean. So that's the box created. Now let's create our sphere. And, well, actually, we do need to move the box up so it sits on the construction plane, because currently, if we bring in the construction plane and go to a side view, I push space 3 to go to a side view and W to go into wireframe, we can see that we're centered up on the construction plane. Now we can take our center Y and we can reference, and we're going to reference a channel. The channel we're going to reference is going to be size Y, which is this parameter here. And we're going to take that and divide it by 2. So we're going to take the 1, which is going to be 1 total height, divide that by 2 will give us 0.5. So now we've moved up 0.5. The beauty of that, if we were to start changing this parameter, let's zoom out. We always sit with the bottom on the construction plane.
Nice.
Fantastic. So now we can create our sphere. So space 1 to come back to a perspective view, and W to bring back shading. And let's drop a sphere in. So I push tab to bring up the tab menu, type sphere, enter to accept that, enter to create the sphere. And I'm going to rename this guy to stage support. And I do want to make a nerve sphere. This is going to be become kind of important when we're dealing with shaders and the likes. And the radius of the sphere, for now, I want the sphere to always be a perfect sphere. So I'm going to make sure that radius in Y and radius in Z reference our X radius. And that means we only have one radius parameter that if we were to change, our sphere will stay perfectly spherical. So that's nice and easy. We can, into radius Y, we can type channel rad X. And the same for radius Z, channel rad X. And that means if we change our radius in X, our Y and Z will come along for the ride as well. Now we do want to take our center in Y and offset this guy down so that he sits with his top on the construction plane, and we saw earlier that to do that we're going to take away our radius. Now I could specify radius X here since I know all of the guys are radius X, but since we're dealing with Y and we're thinking about moving this guy down in Y, for some reason if I was to come back in later and change this parameter to some other parameter, I still want my expression to work. So I am actually going to reference radius Y, since we're dealing with Y and we're dealing with the radius in Y is the important parameter here. So I'm going to subtract radius Y, and that's going to move us down so that we sit perfectly underneath the construction plane. Again, space 3 to come over to a side view, and let's bring up our grid, and we can see that we're sitting perfectly on the construction plane. Fantastic. So if we were to change our radius, we're going to stay with our top welded effectively to the construction plane.
That's right.
So that's our center in Y. So let's also do our center in X and our center in Z. So I'm going to take the same approach that was demonstrated on the whiteboard. I'm going to subtract the half of the width of the box in X and then add back on our radius.
Let's go ahead and make the box visible as well, just so that they can see.
Let's go to a top view.
Yeah.
And make things nice and clear. So I'm going to template in the box by clicking on the template flag so we can see the box here. I'm going to hide. We're seeing a grid. That's because it's an orthographic view. That's fine. So here's our sphere. Here's our box. If we start taking our center in X, I'm going to reference upper level. That's going to take us to our stage. Then I'm going to grab our stage box, and I want to grab his size in X. But we saw on the whiteboard we want to divide that in half since we're already in the middle.
Yeah, yep.
And that's going to move us so that we're sitting on the edge of the box. We need to move back in a positive X direction so that we're flush with the edge of the box. So we can do that by, I'm going to bring up center X in an expression editor to make things nice and clear. We can take our radius in X and we can simply add that back on to this value, and we'll move in flush with the box. We can do the same for Z. Let's bring up the expression editor for Z. So we can subtract our stage box size Z, again, divided by 2, let's accept that. It's going to move us out, sitting centered up on the box. If we take that and we add to it our radius, and I'm going to use radius in Z again, just in case for some reason we change those radius parameters. Since we're dealing with Z here, I'll take radius in Z and add that back on, and that'll push us in flush. Which means if we were to grab our radius and start changing it, we're going to always sit inside the edge of the box. So that's fantastic. That's our first sphere in place. It is worth noting it's gone a different direction to the whiteboard because of the way our axes are. When we look down a top view, positive Z actually happens to be in the downwards direction as opposed to the upwards direction, but it's still working exactly as we'd like. So we can take this guy, we can wire him into a transform SOP, and that's going to allow us to move him down to the other side of that box. So let's right click on the output of the sphere and create a transform SOP. So I typed in transform, I'm going to push enter to accept that, and enter to create the transform. And let's rename this guy so that he makes sense. Let's rename this to something like move to side underscore xform, since we're moving this guy down to the other side. We're going to be moving in Z in this particular case, so translate Z. And we saw we could take our stage box, its size in Z, and if we were to take that, we're going to move down and sit on the opposite side of the box. We've moved from here all the way down its size in Z. So we need to now take our radius and subtract 2 times it to move up back inside the side of the box. You'll also see that we don't have the sphere up here since we've taken this sphere and then moved down. So when we merge these two together, we will have both spheres. So let's take this expression in translate Z and let's subtract from it 2 times our radius in Z, and our radius is up on the stage support SOP, which is our sphere. And let's take our radius in Z. So 2 times that subtracted from it, and we'll move back up on the inside. So now we've got this sphere and this sphere. We can wire this guy into a merge. I right-clicked on the output of the transform, type merge, enter to accept that, enter to create that. And then I can wire our stage support, our original sphere, in by left-clicking on the output and left-clicking on the input of the merge. And I will rename this to merge end spheres. So now we have both spheres coming from here, so we can deal with moving them over to the other side. That's going to move them in X. So I'm going to right-click on the output of the merge, and I'm going to create another transform SOP, this time single left-clicking on transform in our history. And then enter to create that. And I'm going to call this move to end underscore xform. So we're going to be moving in X, so translate X. If we were to take our stage box size in X, we'd move all the way over to this side, and we then need to subtract 2 times our radius in X from that. So let's subtract our stage support radius X, and we want 2 times that. And for those of you who are wondering why when I brought up the expression editor there's a number in there, I accidentally middle-click dragged on the parameter, and that makes it think it's a value ladder and added the 0.1 in there, so I just deleted that out because that was an error. So we take our size in X and subtract from that 2 times our radius in X. And that's going to move those over, so now we can merge all of 4 together. So I'm going to right-click on the output, wire this into a merge, take our 2 from the other end, wire those into the merge by single left-clicking on the output, single left-clicking on the input, and that's going to give us all 4. So I will rename this to merge supports, and since we're going to take our box and wire that in as well, I'm going to name this to merge supports and stage, take our box and wire that down into the merge also. So now if we come to a perspective view of space 1, with our visibility down in this merge, we see everybody. And if we were to change the dimensions of our box, let's use slightly larger values, there we go. You can see our spheres coming along and following along nicely. If we were to change the dimensions here, again. If we were to change the radius of our spheres, everyone follows along nicely. So I mean, we did mention that we're going to promote some of these parameters later. I think I'll actually create the asset now, promote them now, and then we can always come back and add additional parameters to the asset at a later date. Since we got to a nice place where we could do that. So I'm going to grab all of the nodes in our network so far by single left clicking and dragging a marquee around them. I'm going to push Shift C, which will collapse them down into a subnet. I'm going to rename this subnet to stage. We can right click on this guy and come down to create digital asset. And I'm going to rename this to stage. I'm happy with the label being stage with a capital. Again, we don't need any inputs. And I'm going to save this into a new OTL file. So I'll bring up the browser. You can see our floor OTL up in our OTLs folder in our project. This time I'm going to create stage.otl and click accept. So that's going to create stage, and again I'm just going to install it to the current hip file like we did with the floor. So we click accept, we get our type properties come up. I'm going to promote just a couple of parameters from our nodes. So I've come over to create parameters from nodes. I was already taken to the parameters tab. I'm going to come down inside our stage geometry, inside our stage asset, we have our stage box. I want to promote up the size parameter from the box. That's going to be our X, Y, and Z size. I do want to make sure that I'm not prefixing the name or the label. So that's going to bring over the size. And from our sphere, I just want to bring over the radius in X. Since Y and Z are driven by X, we just need that single radius. So I'll bring that over. I am going to rename radius X, the label for that, to support radius. So I changed the label, which is going to be the artist human readable label that will appear on our asset. It makes more sense for it to be called support radius as opposed to radius X. And size I will rename to platform size, indicating it's the size of the platform that's on the stage. So we have two simple parameters. If I click accept, hello Photoshop, there we go. So we have our platform size and our support radius. If we change our platform size, we're going to change the, whoa, that's crazy. Change the size of the platform, the spheres will come along for the ride. If we change our support radius, it's going to change the radius of the spheres.
Very nice.
Cool. So with that, that's the very first part of the stage completed.
Excellent. Thanks a lot, guys.